Kia ora. This is a question that you can do in two ways. If you know and are confident with the sum and the product of the roots, then it's pretty easy to just blast this one out. But in some ways, if you don't use that and you just kind of use your brain, it's just about easier. So let's look at what we've got. The first thing that we're given is we're given a hint, which is we're told that we can write the sum of two squares, a squared plus b squared, in this form here. Right? And I think in some ways writing that first is kind of off-putting, but it really does help us with the second part of the question. So I guess they had to write it somewhere, so they put it at the start. If a and b are the solutions of this equation, find an expression for a squared plus b squared in terms of m and n. Okay, so we're going to use this for when we get down to this part. So let's just start by looking at what we've got. We've got a quadratic, and this is the quadratic in expanded form. But we're told that the solutions of that equation are a and b. It's a quadratic with an x squared, not like a 5x squared or anything. So if a and b are my solutions, that means that I can write my quadratic like this. Now, what we've got to do next is we're going to compare what we get when we expand this with what we've got here. So when we expand all of this out, we get x squared minus ax minus bx plus ab is equal to 0. And that gives us x squared minus a plus b x plus ab equals 0. So right underneath it, I'm going to write out the expanded version. And we can see that they have to be the same equation, right? So that means that m is the same as a plus b, and changing pen colour, n has to be the same as a times b. So let's go back to the start of the question. We're asked to find an expression for a squared plus b squared. So a squared plus b squared, using the hint, or even if we didn't know the hint, we could do this by level 2, is equal to a plus b squared minus 2ab. And we have to get this not in terms of a and b, but in terms of m and n. But we know from here that a plus b has to equal m. So we'll just write that down. And we know that a times b has to equal n. And that's from matching those coefficients up. So a plus b is equal to m, so it's m squared minus 2 times ab, which is n. So that's our final answer there. Now I'm going to do this using the sum and product of the roots. The sum and product of the roots sounds complicated, but all it really is a quick way of doing the matching thing that we just did. And I've done some separate videos on this, and if you haven't learnt this method, then you don't need to know it, but it is a cool thing to know, especially going into level 3 calc. So we've got x squared. If we have a quadratic that is ax squared plus bx plus c is equal to 0, and the roots are alpha and beta, then we can say that the sum of those roots will equal negative b over a, and the product of those roots will equal c over a. And you can see that that's pretty much what we did up here when we were doing it just by matching up. Okay, so if you generalize that, you get this nice result. So in here we've got x squared minus mx plus n is equal to 0, and the roots are a and b. So that means that the sum of the roots, a plus b, is equal to negative m over 1. So we get a plus b equals m, and the product of the roots here is equal to n over 1, which is just n. But we got there anyway, doing it just with what it means to be a solution for a quadratic. And once we've got to there, we can do the same as before. So we've got a squared plus b squared is equal to this. Okay, thanks for watching. I've got one left to do, and I'll do that one later on today.